Hey, what's up, guys? Hey, I am back, and we're going to talk about radicals today, radical expressions and their nth root equivalencies, okay? So let's dig right in. To kick us off, man, first I just want to talk about what the index of a radical is, all right? The index of a radical, how many times a number was multiplied to get a particular number, okay? When you look at a radical, this is your index, okay? This is your index. This is your radicand, what's underneath the radical. And the whole thing is a radical expression. This whole thing combined is a radical expression. But the index guys tell us, like, let's say hypothetically we had 3 cubed. Well, the index will be cubed because 3 cubed is 27. All right, this told us that there's a number that was multiplied to itself 3 times to get this number, all right? So let's just go and look at some examples. Find the nth roots. All right. Well, on this first example here, so we have A. A is going to be our radical. All right. So we have the square root of negative 64. All right. And then we have the n. Our nth is our index cube. So this is a cube root of negative 64. Now, this is not like square roots, this is a cube root. All right, so there's a number that was multiplied 3 times to get negative 64. All right, and that is going to be negative 4 times negative 4 times negative 4. All right, see how negative 4 times negative 4 is actually positive 16, and 16 times negative 4 is negative 64. All right, so the answer here is negative 64. Now, some of you guys may think, oh, wait, no, we can't have a negative. Guys, this is not a square root. Remember when we had those examples like this? All right, and it would be, let's say, 9, all right, or negative 9. Well, see, there's no index written right here. There's no index, so we always imply that there's a 2 there. All right, so that means it's the square root. All right, whenever there's no number written there, that's the square root, guys. All right. But anything higher than the square root, they're always going to put the number. So like the 4th root, right? The 4th root of, I don't know, let's say 625, all right? The 4th root of 625 would be 5 times 5 times 5 times 5. All right, so the 4th root, they would indicate that. But see how right here again, there's no value here, where it's implied that it's a 2. All right, and here you can't have a negative. All right, anytime the exponent is positive, you can't have a negative, guys. It won't work. It will not work. You can't have a radical. But if it's negative, guys, like here's the rules. Let's talk about the rules. Right here, all right. When n is a positive integer, when it's a positive like a 2 or a 4, all right. If a is less than 0, meaning if a is negative, like say this is negative. Even if I had negative 625 right here, there's no real root. So you will have an imaginary number like this one will be 5i. This one would be 3i. All right. There's no real root. It would be imaginary. Okay. But over here, when the integer is odd and the number is less than 0, you'll still have a number, guys. You'll still get an answer, and this is 1 over that number. Like this, you can actually do in your calculator. All right, but we'll talk about that in a minute. For this one over here, we got the 6th root. N is 6, so you have the 6th root of 729. All right, so again, you can do that in your calculator. That's not a problem. Matter of fact, let me show you. So as you can see, man, right here in your calculator, if you press this function right here, math, and then see the 5th, number 5, it says x right here, square root, or x radical. If I press the 5 there to bring it up, and then I just put what I need right here. So I want to go to 6th root of 729. All right, and there you go, it's 3. All right, another way to do it is if you were to go 729, and you can raise it to the 1 divided by 6, because that power is 6, you can raise it like that. is 3. So there's a couple different ways to do it regardless of the calculator that you got, okay? So just wanted to share that, all right? Now back to the notes, we got 3. Now, there's some U tries right here. Give this a try, all right? You give these a try. Now let's go ahead and talk about rational expressions. Let A be a real number and let M and N be positive integers with N greater than 1. Write in radical form. All right. So again, check this out. All we're doing is, let me go back to this example that I used, the 6th root of 7. The 6th root of 729. The 6th root of 729. Oops, 729. There we go. I can rewrite that as 729. Man, 729 raised to the 1/6 like this. All right. Because again, what you do is you have M over N. All right. Where A equals 1 over N. All right. 1, the numerator. All right. Because what this actually means is this. There's an invisible 1 right here. This is 729 raised to the first power. All right, so 729 raised to the first power. All right, that's where the 1 comes from. There's an implied 1 there. 729 to the first power. Because think about anything raised to the 1, like 729 raised to the first, 729. 2 raised to the first is 2. Right, it's just 1, 2. All right, it's just 1, 729. It's just one of them. All right, I'm not multiplying it to anything else. Unlike if I had 2 squared though, all right, it would be a little different, and I'm going to show you how to do that in a second. But for the sake of this, all right, see how this is 1/6? This right here is your denominator in a nutshell. The index becomes your denominator. That's all you need to remember. The index is your denominator. So the radical here would be the square root of, or actually it would be the n root. Here, I don't want to write it right here, it's too small. The n root of A to the M power. All right, like that. All right, so again, remember how I told you this is 729 to the 1? But that's your numerator. That right there is your denominator, okay? The numerator, the denominator of your exponent, okay? This is writing it in exponential form, okay? Right here, let's say it was, all right, so now let's just look at a couple examples, all right? On the back of this, I want to talk about the negative exponent right here. Right here it says evaluate 8 to the negative 4/3. But remember, your denominator, guys, your denominator becomes your index. All right, your index. So this is going to be a cube root. Now, if I move that here, then what we have left is 8 to the negative 4. All right. Well, we don't want to have a negative exponent. Anytime you have a negative exponent, we're going to move it to the bottom. All right. Take the reciprocal of this so we can have a positive exponent. So we're going to do this 1 over 8 to the 4th. All right, 1 over 8 to the 4th. The denominator is your radicand. The numerator is your power, just like I talked about a second ago over here. All right, that's your numerator. That's your denominator. Okay. The only difference here is, yeah, this is a negative 4, but we don't want a negative exponent. All right, we want to move to the bottom so it'll be positive. So what you get is we're going to evaluate. Wait, it doesn't even say, it's just rational. All right, so I'm sorry. We're going to make this rational. All right, so let me backtrack. I'm going way too far. All right. All right, for this portion right here, all right, it just says rational exponent form. So to make this rational, remember, you don't want a negative exponent. So we're going to move it to the bottom. Like that. That was positive, okay? So now we bring it over here. Let's just put it in radical form. Now this is what I was doing a second ago. In radical form, you're going to have, remember, the 3 is your radicand, your index. The 3 is your index. and then you have 1 over 8 to the 4, 8 to the 4th power. All right, you can do it like that, okay? Or you can rewrite it like this, guys. There's a couple different ways to rewrite it, because that 1, the cube root of 1 is 1. 1 times 1 times 1 is 1. You know what I'm saying? Or you can write it like this, 8 to the 4th, all right? You can write it like that. All right, it's the same thing. This is radical form, this is radical form, okay? Either one for me is acceptable. So rational exponent form is just taking that and there's no making it positive. All right, it's no longer negative. But remember, the thing to remember is your denominator is your radical. Excuse me, your denominator is your index, and the numerator is your power. Okay. So now, right here it says approximating roots in your calculator, 9 to the 1/5. Well, again, guys, 9 to the 1/5. Remember I showed you how you do 729 to the 1/6? Well, you can do 9 to the 1/5. All right. If you just did 9, hold on, let's do this. Let me go back. If you do 9 and then raise that, oh, hold on, calculator's on the fritz. I'm trying to get 9 raised to the 1 divided by 5. Like that, all right? There's your approximation. Now, let's say hypothetically your calculator doesn't do this right here. It doesn't actually raise it. Well, you can do 9 raised to the, in parentheses, 1 divided by 5. That's actually what the directions say. All right, raise it to the parentheses 1 over 5. But make sure you put parentheses around your whole exponent. And we'll say about 1.55, all right? 1.55. But for the sake of this, I want you to write this as an exponent. Remember, that's your denominator. I mean, the denominator is your index. So the 5th root of 9 to the 1st. Okay. This one would be we're gonna rewrite it as an exponent first. I mean, as a radical first. So again, the denominator 8 is your index. You have 8, the 8th root of 12 cubed. All right, the 8th root 12 cubed. And then we can solve that. All right. So back over here, we put in our calculator. We can go 8 raised to the, what was it? No, it wasn't 8. It was 12. Sorry about that. 12 raised to the 8. No, 3/8. All right. Again, yours doesn't do this. Put parentheses around that, okay? But 2.54 is the answer. All right. And then this one right here. This one just says rewrite it. See how this is equal to 7? We're gonna rewrite this. So remember, that's the power, that's the radical, but that's the numerator. All right. That's the numerator. The index is your denominator. So 7 3/4. All right, then just solve that in your calculator, okay? Now, this one right here, it says solve equations using end roots. Well, first of all, see this here, we can divide by 2 on both sides. So we get x to the 729. All right, and now we solve this. How do you remember how we had x squared in the last unit equals 9, and then we go square root on both sides to get rid of the square, right? Well, think about it, this is 6th root. So what I'm going to do is I'm going to take the 6th root on both sides. All right, so the 6th root is 729, guys. And again, you can go to your calculator. All right, the 6th root is 729. So I'm going to go math. And there it goes right there, that 5, that 5th option. The 5th root of, no, the 6th root, I'm sorry. 6th root of 729. And that is 3. All right. So the 6th root of 729 is actually plus or minus 3. Because again, it's a positive root. Remember how when you take the square root of 9, you get plus or minus 3? Anytime it's a positive exponent, it's going to be plus or minus, okay? Over here, a little different, all right? See the parentheses? The parentheses right now are in jail, all right? They're in jail, but what's outside of that? Let me make this a little bigger. That's a lot bigger. But what's outside of the parentheses right now? The cube. See the cube? So to start this one, I'm going to go ahead and cube both sides. Cube root both sides. So we get your 3 right there, your index. All right, when I cube root both sides, I get x. Well, here, the radical and the exponent cancels. So it's x plus 4 remaining equals the cube root of 12. All right. Now all I got to do, there's no cube root of 12. There's no number that'll give you 12 if I multiply 3 times. So what I'm going to do is I'm going to go ahead and subtract 4 on both sides. So I end up with x equaling, you can write it as -4 plus the cube root of 12. All right, like that. Now, there is this word problem right here, guys. Again, it's a word problem. Don't freak out about it. Let's look at the critical information of what we need. It says animal population. I will use the roots to solve the problem. The population P of a certain animal species after T months can be modeled by this equation right here. So that's important. Where C is the initial population, all right, and P is the population. Find the population after 19 months if the initial population was 75. All right, the initial population was 75. So we're going to go ahead and make this equation right here. All right, what it should look like is this. Remember, C is the initial population, so that's 75. All right, so C times 1.21, all right, and then time. We have time right here. It was 19 months. So we're going to say 19 divided by 3, because again, I got all this from right here. C is the initial population. They said the initial population is 75, so that's C, all right. And then T is 19, because they said after 19 months. Well, T is right there, 19. All right, so there's the equation. So now all we gotta do is find P, find the population, all right. So I solved this right here. 75 times 1.21 raised to the 19 over 3. All right, so when I do that, you have 75 times 1.21 raised to the 19 divided by 3. I'm going to do this in parentheses just so you guys can see it. 19 divided by 3. Make sure you put this in parentheses. And enter. So 250.8. So we're going to say that the population after 19 months is about 251. We'll say approximately 251 after 19 months. So whatever it started with, 75, after 19 months, that's 250 of that species, okay? Here's a couple U tries, all right? A couple U tries. I'm going to go ahead and write the answers in, and you try it and see if you get the same answer I got, okay? So yep. So here is the U try. All right, the one thing I want you to remember is that, see how this is a positive exponent? Remember, when you have a positive exponent, you will have plus or minus. Don't forget that. And then here's the solution to down here. Oh, you know what I forgot? That equals R, all right, because we're solving for radius. And R is the radius. All right, so we're solving for R. So this was going to require all the algebra skills, you know, okay? That is really it, guys. All right, I hope this helps. Please remember to bring me questions from the video. Any question you got, I would love to hear from you, okay? All right.